Alright, we're going to start chapter 5, which is on probability. And for the next, I don't know, 5 videos or something, I'm going to be taking old videos and just editing the start of the video and the end of the video. So you're going to notice these little glitches in the video where things are going to look suddenly just a little bit different. But I think it's all going to work out. And now also the sheet that I've given you that looks just like I have here, it might change a little bit as well. I think you're going to see suddenly it's going to be all numbered and everything. So I'm sorry if it's just tiny bit not as smooth as usual. I apologize. But as I said, I think you can handle it. So today we're talking about probability. So what's probability? You know this, right? It's the likelihood or the chance of something happening. So when we talk, back here, I asked you, where'd that die go? One dice is a die, right? What's the probability of me spinning this and getting a 2? Am I going to get 2? No 2. What was the probability? I know lots of you know the answer is 1 over 6, isn't it? Okay, we're going to explain that to you. So probability is the likelihood of something happening. We got a couple other terms here. Outcomes. Outcomes are different ways an event can happen. So what I mean by that, let's think about the dice here. If I think of my event, if I think of my event as being rolling a die, what are some of the outcomes? Well, what are some of the different ways things could, what are different things that could happen? Well, I guess one thing that happened is I could get a 1, or I could get a 2, or I could get a 3, right? These are all outcomes when I roll a die. That takes us to the next one. What's the sample space? The sample space is all of the possible outcomes. So again, if we're talking about the die, what is the sample space? It's all the possible outcomes. So what are all the possible outcomes when you roll a die? You could get a 1, you could get a 2, you could get a 3, you could get a 4, you could get a 5, you could get a 6. So that's the sample space. Outcome is any number of those, right? 1 is an outcome, 2 is an outcome, 3 and 4 are outcomes. But if you're talking about the sample space, you have to list all of them. Okay, favorable outcomes. Now, this is kind of a problematic word, this word favorable, because when we think of favorable, we always think of like something good, right? Easter's favorable because we get chocolate, sort of thing. But in probability, it's not necessarily something good. Favorable outcomes are the events you're interested in. So I'm going to try to give you a weird example here to show that the ones you're interested in aren't necessarily good ones. Let's say that I played this game with my friend. Great game, played all the time with my friend. We roll a die, right? And if 1, 2, 3, 4, or 5 come up, he pays me $10. But if the 6 comes up, he chops off one of my fingers. Oh, great game, great game. So I want to know what the probability of getting 6 is. So the way we write that, well, I'm just going to write this. Probability of 6. So if I was to try to figure that out, the favorable outcome, the ones I'm interested in, is getting 6. Now I hope you agree with me that the 6 isn't actually a good thing. Me getting my finger chopped off, not really that crazy about it. But the reason we call it favorable is because it's the one I'm interested in this case. I'm interested in what the chances are of getting a 6 when I roll the die. Okay? I just don't want you to think that favorable always means, oh, the good one, because favorable can be a bad outcome. It just happens to be the one that you're interested in. I hope that makes sense. Okay, what is the actual formula? So this is the most important thing. If you only write one thing down, please write this down. How do you figure out the probability? So, for example, I bet lots of you already knew when I asked you, back here again, when I asked you, what's the probability of spinning this die, or rolling this die, and getting a, what did I say, 2 or something? Well, I didn't get it. And a lot of you knew the probability is 1 out of 6. I bet a lot of you knew that. I hate this, how this always happens. So, how come the probability is 1 out of 6 when you roll a die? What are each one of those numbers? If I want to know the probability of rolling a 2, instead of writing the whole word probability, it takes too long. You just put capital P, and then what you're interested in, the favorable outcome, you put it in brackets. So the probability of rolling a 2 is 1 over 6. How come? What do each of those numbers mean? What's the bottom number refer to? That's the total number of outcomes, right? When I roll a dice, I can get a 1, a 2, a 3, a 4, a 5, or a 6. I already wrote that up here somewhere. There we are. How many are the total right there? There's 6 of them. So that's the bottom number. What's the top number? That's how many of the outcomes are favorable. Well, in this case, the only favorable outcome is 2. There's only 1 of them, so it's 1 out of 6. So our formula is probability is equal to the number of favorable outcomes, the ones we're interested in, right, divided by the total number of outcomes. So just let me do one other example. Well, I'll do a bunch, but let's do one right here. If I was interested in the probability, again, rolling our dice, and getting 2 or 5. I want to know what the probability of 2 or 5. Okay, so let's take a look at the bottom number. How many total outcomes are there when you roll one die? 6. We just talked about that. 1, 2, 3, 4, 5, 6. Okay, how many favorable outcomes are there? 2 is favorable, but 5 is also favorable, so this time it would be 2 out of 6 is our probability, which you then put in lowest terms, 1 over 3. Okay? Once you see a bunch of these, I think it'll, if you haven't figured it out yet, you'll get it when we do a few more of these and a few more of these. Okay, so coins. We're often talking about dice, coins, spinners, cards. Those are the main things we're talking about when we talk about probability in grade 8. So if I flip a coin, I want to know what the probability is of getting tails. So I'm going to put the probability of tails is equal to, okay, how many outcomes total are there when I flip a coin? Well, when I flip a coin, I can either get heads or I can get tails. That's it. There's only 2. Don't give me the, oh, it could land on its edge or something. This just does not happen in real life. So there's only 2 possible outcomes, heads or tails. Top number. How many favorable outcomes are there? Well, if I'm interested in the probability of getting tails, tails is the only favorable outcome. There's only one of those. So this is our probability, 1 over 2. All right, how can a probability be expressed? There's actually 3 ways you can express a probability. You'll notice so far what I've been doing for all these questions is I've been using fractions, and I'd say that's the most common. Please try to put your fractions in lowest terms. So notice I didn't stop at 2 over 6. I put it to 1 over 3. There's actually 2 other ways you can give a probability too. You could also give it as a decimal. So for example, with this coin question I just did here, instead of writing 1 over 2, what's 1/2 as a decimal? It's 0.5. So you could also say the probability of getting tails is 0.5. What's the third way you could give a probability? This is probably the least common, maybe. The third way you can do is you can give a percent. So 1/2 is equal to what is a percent? 50%. All 3 of these answers mean the same thing. Probability of getting tails is 1 over 2, which is equal to 0.5, which is equal to 50%. So when you're looking at your answer book and everything, you might want to sneak a peek and see which way they've expressed their answers, so then you can put yours in similar form to check your answer. All right, number 8, dice. Oh, well, we've just been dealing with dice a little bit here. What's the probability of getting 5? Well, again, I don't think we have to spend too long on this because we just did it. How many different outcomes are there when we roll dice? 1, 2, 3, 4, 5, 6. There's 6 of them. The only one we're interested in is 5. Don't put 5 up here, because how many favorable outcomes are there? Only one outcome is favorable. The 5 is the only one that is favorable. Okay, the probability of getting even. I don't know why I'm writing this down. It's written right there. Anyway, when you roll a die, how many possible outcomes are there? 6. This is always going to be 6. How many of them are even? You know your even numbers? 2, 4, 6, 8. Wait a minute, there's no 8. We're talking about a standard dice here. So that's it. 2, 4, 6. There's 3 favorable outcomes this time. So we get 3 out of 6. Happy with that answer? No way. We want it in lowest terms. So this would be 1 over 2. Okay, the probability of getting 9. I know, don't start screaming at me. I just want to show that it still works to do the same thing we've been doing. How many outcomes are there when you roll dice? 6. We've done this every single time. 6, 6, 6. 6, 6, 6. So how many favorable outcomes are there? The only favorable outcome is a 9. How many 9s are on a standard die? None. There is no 9. There is no 9 on a die. So we get 0 over 6 as our probability. Guess what we can put that as? 0, right? Or 0% if you want. All right, spinners. So here's our spinner right here. If I was to spin this spinner, what's the probability of getting red? How many total outcomes are there? There's red, there's yellow, there's green, there's blue. There's only 4 outcomes, so that's my bottom number. How many of those are favorable? In other words, how many of them are red? Only one of those sections is red. 1 out of 4 is our answer, or 25%, or 0.25. What's the probability of getting a color? What the? Okay, let's think about this. How many possible outcomes are there? 1, 2, 3, 4, just like before. How many of them are favorable? Is red favorable? Is that a color? Yeah, it is. Is yellow favorable? Is that a color? Yeah, it is. Is green a color? Yes, it is. Is blue a color? Yes, it is. All of these are colors. So our number of favorable outcomes is 4 to 4. If you put that in those terms, you get 1. What's that as a percentage, by the way? 100%. Okay, you have a 100% chance of getting a red one. Hope that makes sense. You spin this, you're getting a red one. Sorry. You have a 100% chance of getting a colored section here. You spin this thing, you're getting a color. Okay, what's the probability of getting green or yellow? So, how many total outcomes are there? We count them all up. 1, 2, 3, 4. Oh, same answer we got here, same answer we got here, same answer we got here. 4. How many are favorable? Is red favorable? No, we want green or yellow. Is yellow favorable? Yes. Is green favorable? Yes. Is blue favorable? No. So how many were? The yellow and the green. 2 out of 4. Happy with that? No. We want this to be in lowest terms. Or 50%, or 0.5. Any of those 3 answers work for me. Okay, what's the probability of not blue? Oh, interesting. Okay, works the same way. Bottom number, total number of outcomes. 1, 2, 3, 4. Every single one of these questions has 4 on the bottom. Okay, favorable ones are not blue. Is this favorable, the red? Yes, that's not blue. Is this yellow one favorable? Yes, that's not blue. Is this green one favorable? Yes, it's not blue. Is this blue one favorable? No, blue is blue. It's not blue. So these 3 are favorable. 3 to 4 is your answer, or 75%, or 0.75. Okay, probability can be as small as, what's the smallest number you can get? 0, right? That's the smallest you can get. What's the biggest you can get? Okay, let's do this in percents. 0% is the smallest. The biggest you can get is 100%. It doesn't make sense for something to be 110% probable. It does not make sense. If you do it in decimals, this would be from 0 up to 1. What does 0% mean? 0% means that this is not happening. Me rolling a die and getting a 9 is not happening. It's impossible, basically. What does it mean if something's 100%? That means it must happen. Me rolling a die, or me spinning the spinner and getting one of those colors, getting a color, it must happen. There only is colors on here. So 0% not happening, 100% must happen. We've got to skip to number 12. I put these questions in the wrong order. What's the sum of the probabilities of all the outcomes in a sample space? Toughest question that we're going through today. If I added up all the probabilities, do you know what it will always add up to? So for example, what's the probability in the spinner of getting red? Getting red was 1 over 4. We got that right here. What's the probability of getting yellow? 1 over 4. Green, 1 over 4. And blue, 1 over 4. If I added those all up, I'll just do that down here. If I added up the 1 over 4 plus the 1 over 4 plus the 1 over 4 plus the 1 over 4, what do I get? Well, the denominator stays the same. I had 1 plus 1 plus 1 plus 1. I get 4 over 4, which is the same as 1. Oh, the sum should always be 1. Or if you're doing percents, 100%. Has to always add up to 100%. So with that in mind, if the probability of something happening is 0.3, what's the probability of it not happening? Remember, it always has to add up to 1. So if the probability of it happening is 0.3, then it has to be 0.3 plus something, and it has to equal 1. Hey, we could use a little algebra here. Why don't we subtract 0.3 from both sides? So we get question mark equals 1 minus 0.3. The answer is 0.7. That makes sense, right? 0.3 plus 0.7 equals 1. And it always has to equal 1. Or 100% if you're doing percents. If we're doing percents, this would say 30%. If the probability of something happening is 30%, the probability of it not happening are 70%, and that adds up to 100%. All right, everyone, I know that was pretty fast. Oh, but wait, I wanted to go over this question with you. If I was to spin this spinner, what's the probability of getting 3? Now, here's a very common mistake people make. They say, all right, I want to know what the probability is getting 3. So how many outcomes are there here? 1, 2, 3. So there's 3 outcomes. How many of them are favorable? The only favorable outcome is the 3 here. So it's 1 out of 3 is your answer, right? Wrong. What's wrong about that? What's wrong is they're not all equal chances, right? The one has a way bigger chance than the other ones. I mean, if I spun this blue arrow here, I'd be more likely to get the 1 than the other ones. So anyone see what I should do? I should kind of put like a line across. This section up here is number 1, and this section down here is also number 1. So it actually ends up there's 4 sections here. So if I wanted to know what the probability is of getting our 3, how many total sections are there? 1, 2, 3, 4 possibilities. How many of them are favorable for the 3? Just 1. Now, what if I want to know the probability of getting a 1? There's still 4 sections. How many sections are favorable this time? This one's favorable and this one's also favorable. It'd be 2 over 4. So we'd have a 1/2 chance, or 1/2 probability of spinning a 1. Okay, there you go. Day 1 of probability is done. We'll continue on in the next video, which will be a short video on tree diagrams, they're called, that people always struggle with them. So we'll see you for that video. Have a good day. Bye.